You ever really truly look at a simple piece of thread? I mean, it seems so basic, right? Almost boring. But what if I told you that inside every single yarn, there's a hidden, super complex, and constant dance going on that actually gives it its strength? Well, today, we're going to unravel that mystery. We're going to explore the microscopic choreography that turns a bunch of simple fibers into a really powerful thread. So, what is that secret? Well, it's not just about what the yarn is made of. Nope. The secret is all about movement. It's this invisible choreography happening at a microscopic level that turns a loose puff of fibers into something robust, something unified. Just try to picture it, all these individual fibers coming together. They aren't just twisted and then locked into place forever. Not at all. Instead, they're in constant motion, literally swapping places, weaving from the outside to the core and then right back out again. This dynamic movement, that is the real key to its strength. Okay, so this secret dance, it actually has a name, and it's the entire focus of our explainer today, fiber migration. It's the engineering principle that separates a weak fluff of fibers from a strong, resilient yarn. So what is it exactly? Well, to put it simply, fiber migration is the journey that individual fibers take inside the yarn structure while it's being spun. They're not just stuck in one lane. They weave through the entire cross-section of the thread. So why do they move? Okay, think of it like runners on a track. The fibers on the outside have a much longer spiral path to travel. This puts them under way more tension. Meanwhile, the fibers in the center have a shorter, straighter path, so they're under less tension. It's only natural, right? The high-tension outer fibers want to relieve that stress, so they push their weight inward. And in doing so, they push the more relaxed inner fibers outward. This creates a non-stop, continuous cycle of movement. And listen, this isn't just some casual idea we're throwing around. It's a formally defined principle in textile science. The Textile Institute itself defines it just like this, as the constant change in a fiber's distance from the center axis of the yarn. Okay, so we've got the what and we've got the why. But the real question is, who cares? Why does any of this matter? Let's dive into how this tiny little dance directly affects the strength and the quality of the clothes you're wearing right now. Well, for starters, the intensity of this migration isn't random at all. It's controlled by a few key things. For instance, longer fibers, they tend to migrate more. Higher tension during the spinning process? Yep, that increases it too. And crucially, the spinning method itself, how the yarn is actually made, plays a massive role. And this is where it all comes together. More migration means the fibers are interlocking better. They're gripping each other more effectively, which translates directly to a stronger, more elastic yarn. It's the difference between, say, a loose bundle of sticks that just falls apart and a tightly woven rope. Still not convinced? Need some proof? Get this number. Rotor spun yarn, that's a method that results in very little fiber migration, is consistently 15 to 20% weaker than ring spun yarn, where migration is happening all over the place. That is a huge difference in performance, all because of this invisible dance. Now, this all sounds great in theory, but it presents a huge scientific challenge. If this whole process is so important, how on earth do you actually observe it? How do you watch something happening inside a solid thread? I mean, really think about it. The yarn is dense, it's completely opaque, you can't just peer inside. For decades, this was a major roadblock for textile scientists who were trying to really understand and perfect the spinning process. And then came this absolutely brilliant solution. It's called the tracer fiber technique. The process is just pure genius. First, you mix in a tiny amount of colored fiber. We're talking less than 1% with the main batch. Then, you spin the yarn like you normally would. But here's where the magic happens. Step 3. You dunk the yarn in a special liquid that has the exact same refractive index as the uncolored fibers. And poof! The bulk of the yarn becomes essentially invisible, leaving only the colored tracer fiber for you to see, clearly showing its winding path through the yarn. Incredible, right? And you know, a breakthrough this big, it's never the work of just one person. This was an evolution of scientific inquiry, built by researchers who were totally dedicated to measuring this hidden world. It really started with the mathematical models from researchers like Gupta. Then you had Morton and Yen, who came up with that game-changing tracer fiber technique for staple fibers, like cotton. And later, a scientist named Whiting adapted and perfected it for continuous filament yarns, like nylon. So this diagram here, this gives you an idea of what those scientists were working with. That wavy line, that's the colored tracer fiber, weaving its path through the yarn, all ready for that crucial next step, making everything else around it just disappear. And this is how they actually measured it. Once the yarn was basically see-through, they'd place it under a microprojector. Using these really precise scales, scientists could map the tracer fiber's exact position, all its peaks and valleys as it migrated from the core to the surface and then all the way back again. But of course, science doesn't just stop there. Writing took this a whole step further. He developed a much more complex setup to get even more accurate data, which was especially important for those super smooth filament yarns. And wow, just look at this diagram of Writing's setup. He used a carefully placed light source and a system of mirrors to create an image of the yarn and that single black tracer filament inside. This let him take hundreds of precise measurements along just one piece of yarn, creating an incredibly detailed map of the fiber's migration path. I mean, it's just a testament to the dedication it takes to understand these really fundamental processes. So the next time you pull on a t-shirt or just use a simple piece of string, remember the invisible dance happening within, a constant migration of fibers precisely engineered just for strength. It really makes you wonder, doesn't it? What other hidden structures, what other invisible dances are holding our world together?